In this part of the lesson, we're going to talk about the intermediate value theorem. I'm going to read it, and it should just seem like words right now, blah, blah, blah. If f is continuous on a closed interval ab, then f takes on all values between f of a and f of b, blah, 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 blah. Let's make crystal clear sense of this. I often call this the no-duh theorem because it is so straightforward. Let me give you a little example. Here's a little mountain. Now that mountain is brown, so I fear to say that that is not a mountain, but a pile of something else, but let's ignore that for now. Suppose when I started climbing the mountain, I was at an altitude of, let's say, -5. So you might say 5 units below sea level. Doesn't mean you're actually underwater, just 5 units below where the sea touches the land. And at some point, I take a break, and at that snapshot in time, I am at a sea level of, let's say, 4, +4. Now, the question is, if I start at -5 and I end up at +4, will I ever pass through sea level? Geez, you don't need a drawing to answer that. You say, of course you'd pass through sea level. If I go from -5 to 4, I have to pass through 0. No, duh. And that's really the point of the no-duh theorem. Now, how many times did I pass through sea level? Well, if the only information I know is I start here and I end up here, the only thing I know is at least one time. And so this is a theorem that guarantees that you take on all values, in this case between -5 and 4. And some people want to argue, hey, wait a minute. I can go from -5 to 4 if I teleport. Geez, I guess you're right. If you go from -5 to 4 and you teleport, you don't necessarily pass through sea level to get there. So you're right about that. And that's why this is important. It says f is continuous, basically, for all values between a and b. And since it's continuous, you're not teleporting. This intermediate value theorem is often used to determine if there is a guarantee to have a 0. So for instance, suppose I had a function. Here, I'll draw the axis real quick. And suppose that the function started here and ended here. And you would say, does this function guarantee to have a 0? And the answer is, well, depends. Is it continuous? So if I say the function is a continuous function and I start here and I end up here, then you say, well, yes, there's at least one 0. I can't draw these two connected without passing through a 0. But I also, given those same 2 points, okay, I could also have a different function that did this, and so pass through many points. So the guarantee is that we had at least one 0. In a different scenario, suppose that I started here and I ended up here. Does this function have any 0s? Well, it could have. There's just no guarantee. See, if I drew a curve like this, well, then there are no 0s. But if I draw a curve like this, well, then it has several 0s. So we use this intermediate value theorem to guarantee certain y values will be obtained. Here's a table of values, some x and y values, and the given information tells us this function is continuous at all points between -4 and 2. And in part A, it wants to know how many times will the function obtain the value -120. It's important that we state, even though it's given, we want to state it because it's important to this. There's no teleporting. F is continuous on -4 to 2. Okay, that was given to us. Now, since it's continuous everywhere on -4, 2, it's also continuous. I'm viewing this now and I want to obtain the interval that's of importance to me. F is continuous on the subset interval -4 to -3. And on that interval -4 to -3, f goes from -139 to 72. where we say f obtains all values between negative 139 and 72. And so on this interval, negative 4 to negative 3, f must equal negative 120 at least one time. We also look at some of these other intervals. No, there's no guarantee it passes through negative 120. There's no guarantee here. There's no guarantee here. There's no guarantee here. There's no guarantee here. So we can only guarantee that f will obtain negative 120 at least one time. It is possible that the graph did something crazy like this, and maybe we caught another one down here. We just don't know, so we can't guarantee it. And this should say 1, not on. In part B, it wants to know how many zeros there will be. F is continuous on negative 4 to 2 means that it's continuous for all values. X is negative 4 to x equals 2. And also I'm going to note that F has 3 sign changes, and therefore f must have at least 3 zeros. There are no practice problems I'm offering for this section. I just want to introduce it now. We will definitely revisit this intermediate value theorem at a later time.